Hello everyone. In today's video, I will be going over the 2-2 notes for transformations of parent functions. So if you were in class, you already know that these notes took quite a bit of time to fill out. So for the video, I'm going to do what I wish I would have done the first time around. So a lot of what you see here on the notes, I'm not going over. That's stuff we can tackle much closer to the test when we're going to be putting everything together. The point of these notes is for you to be able to understand the different transformations and to know which one you have based on your equation. Also, you're going to want to have the 2-1 parent functions notes at least close by while I'm doing this, or at the very least I'll be showing you with mine. There's a lot of overlap between these two notes, and I'm going to be going back and forth between the two. Before I can explain transformations, the first thing I need to show you is how to find the vertex of an equation. So we have something called vertex form, and it looks like this. Now this notation, don't worry too much about the different letters, and this can go for several functions. So I could have a squared here, a cubed, I could have absolute value, I could do this with the square root, I can do this with most functions. So this is just a very generic form. And the vertex of the equation is hk. Something that's important to notice is that my vertex is a positive h, but in my equation it's a negative h. So that's something to keep in mind. So here's my example. Y equals x minus 5 whole thing squared plus 6. And I want to find the vertex of this equation. So let's label the spots. I've got h is right here and k is right here. Now again, h is negative. So when you put a number in for h, that negative means the sign is going to change. Let me demonstrate. So these are two different just side examples just to demonstrate the point. Let's say h is 3. If h is 3, then when I plug it into the parentheses, h will go here. Now it looks like a negative 3, but it's just a 3. Let me demonstrate if h were negative. Same thing, I plug it in. Now here's the reason why. This minus is always there. If the 3 is positive, I still put the minus. If the 3 is negative, I still put the minus. So this is how you would properly write it. And then we know that two negatives in a row make a plus. So this would actually just become x plus 3. So what I'm getting at here is that the actual value of h is the opposite of the sign you are seeing. This is going to be one of the most confusing parts of the notes. So if you can remember that, you are going to be just fine. So here, h appears to be negative 5, but h is actually positive 5. So you are going to change this to negative or to positive 5. When you write the vertex. Not in the actual equation, keep it at minus, that's how you write the equation. But mentally change to plus 5. So my vertex, my h is 5. K is easy, k is keep. You keep it the same, so this keep 6. No change. The plus here means we're not going to change the sign. If k is 6, you plug it in for k, it's still a plus 6. If it were a negative, then it would be plus negative 6, and it would still be negative 6. So that's what's nice about the k. K, you don't have to worry about. H, you do. You have to remember that too. Some students will keep both the same. Some students will change both of them. And I'm sure at least one student is going to change the k and keep the h. You have to remember, if it's inside the parentheses with the x, you change the sign. If it's outside by itself, like the k is, then you keep the sign, whatever it is. So the reason I'm showing you this is because when we're making these graphs, step 1 is to always find your vertex, or in some cases we call it the starting point, but most of these it's called the vertex. So you want to find your vertex first and foremost. So looking at this first example, I have f of x equals the absolute value of x minus 2. So we have our h and then our k. Notice that there is nothing in the k spot. Well, our number for nothing is 0. So k is actually 0. And then h, mentally, we're going to change this to a plus 2. So our vertex is at 2, 0. So we have 2, 0. And then to graph the rest of the things, I'm just going to give you the points for now. So I want you to graph, so we graph 2, 0. I want you to graph 1, 1. And 3, 1. 3, 1. The expectation for our tests and quizzes is that you graph 3 points. That's it. So if you graph those 3, you are going to be just fine. If you want to graph more, you can, but you don't have to. And it should look something like that. So, the culmination of this, the big point is, let's look at the before and after. So this is the original graph, the parent graph, which is just the absolute value of x, and then this is our transformed absolute value of x function. What's the difference? What did we do from the original to the new? We took the whole graph and we moved it to the right. So our transformation is right 2. Now if you think about it, and this is what trips students up, this looks like a -2, so typically you would think of this as moving to the left. However, when we have to mentally change it to +2, that actually makes sense because right is a positive movement. So if this is actually a +2 in disguise, then we are moving it to the right too. But without doing that mentally, and you just look at that and see that negative, you're automatically going to think left. Remember, we changed the sign mentally. So it's actually a +2. So it does go to the right. Number 2. On your paper, this is a -3. Make sure you change it to a plus. If I kept it a minus, it would work exactly like number 1. So that is my bad. That is me actually altering the problem and fixing a mistake. So first step is to find the vertex. I meant to write that out up here. I'll do that right here. First, find the vertex. And when we actually work out the graphs by hand, by yourself, this is always going to be the first step. So that's why we're doing it today. So we got our h and k. Again, there's no k, so that means k is 0. And then the h, we mentally change this to a -3. It says plus, it's a -3. So my vertex is -3, 0. So I'm going to plot that right here. So I have -3, 0. Next, I want you to plot -2, 1. And that looks like 1, 2. Those are the points I want you to plot. And then when we draw our graph, what's important to remember with the square root is that it just goes to the right after that. Okay, let's observe what happened here. Again, here we have the original, and here is the new graph. As you can see, the original starts at the origin, 0, 0, and the new graph moved 3 to the left. So our transformation is left 3. And again, this little vertex trick is directly related to the transformation. So without changing the +3, that you would assume is our right 3. But mentally, we change this to a -3 for the vertex, and that also means we're moving it to the left 3. Minus is a left movement, so that makes sense. On these next two, we're basically altering the equation without a graph. Write the equation of a function with the following transformations from the parent graph. Y equals x cubed. So this is the original. Now we need to change it to reflect these shifts. So we have y equals, we're moving left or right, I'll need to put parentheses around here. So the cubed goes outside the parentheses. It's not x cubed plus or minus the number. It's x plus or minus number, whole thing cubed. We're moving 3 units. To the right. Right is a positive movement. But remember, when it goes in here, we change the sign. So this is a minus 3. Over here, we have our parentheses cubed. And then we're moving 12 units left. Left is a negative movement, so it's a negative 12, but when we put it in here, we change it to a positive 12. So that's how it's going to look in the equation. So let me sum this up. If you have x minus h, and the h is coming from that vertex form on the front that I showed you. If we have x minus h, we're going to do the opposite of the negative. We're going to move right, a positive movement. If we have x plus h, we move left. Because again, mentally, this plus becomes a minus, and left is a negative movement. So this is kind of like your little shortcut here to remember how this works. Now let's get into vertical transformations. So again, first thing we want to do is find the vertex. Now this is something that once you've seen it side by side, it makes more sense, but maybe at first this is a bit confusing. We don't have an h here because we don't have x with something in parentheses squared. So this would be like x plus 0 because there's no extra number in there. So this we don't have an h, so h is 0. So h is 0, and then k is 4. K is outside of the x, so it's by itself, so we keep it. So our vertex is 0, 4. Again, this is confusing for a while, but once you've done enough examples, it makes more sense. So 0, 4 is my vertex. And then I want you to plot 1, 5 and negative 1, 5. Then it has a U shape, so it's going to look something like this. It doesn't have to be perfect. Now let's compare this back to the original notes. Originally, the vertex is at 0, 0. Here, it is all the way up at 4. So this graph moved up 4 units. Up 4. It didn't move left or right, just up 4. And notice that's the same as my k. So 0, because it's not moving left or right, and up 4. So it's just moving up 4. Number 6. Side note, these exponential problems, these are tricky just in general. So I'm just going to go and tell you now, for this unit, we are not going to do any left or right with these exponential problems, only up or down. So just an FYI when you're looking at this. When you graph these are graphed special. This minus 1 here is your asymptote. If you remember from the notes, the asymptote hugs the bottom of the graph, and it's this line that our graph is not allowed to cross. So on the original notes, on the parent graph notes, we just had 2 to the x, so that's like the same as 2 to the x plus 0. Our asymptote starts at 0 here. So here, it's 2 to the x minus 1, so our asymptote is at negative 1. And this works very much like the y-intercept. Go to this number on the y-axis, but we're not going to put a point here. We're going to put a dashed line through it. So first we graph the asymptote. And then notice we don't have vertex here, it's starting point. For the starting point, it is 1 point above the asymptote on the y-axis. Just trying to be extra clear here. So you go to the y-axis, the asymptote is at -1, so we go up 1, 0, 0 is where our starting point actually is. And so the correct way, or the point itself is 0, 0. And also our asymptote, the right way to write this is y equals -1. So not just -1, y equals -1. It is a whole line. For the other points, I'm just going to tell you what to graph for now. We're going to work on graphing this more next week. I want you to graph, so we have 0, 0. I want you to graph 1, 1. And then I also want you to graph 2, 3. When we graph, first I'm going to go up, and it's going to go up towards the sky. Not perfectly straight, it's still going to curve out to the right. Now the bottom is going to come down, and it's going to get as close as it possibly can to this asymptote without crossing it. That's it on the exponential. Oh, I didn't do the transformation. So here's the original. This is 2 to the x, and this is 2 to the x minus 1. The difference is subtle. I always look at the asymptote to figure out what happened to it. Here, the asymptote is at 0, y equals 0 on the y-axis. Here, it's through -1 on the y-axis. So this graph moved down 1 unit. So here's the thing, this -1 is not only the asymptote, it's also the movement. So it has two purposes here. Last page. Write the equation of a function with the following transformations from the parent graph y equals the absolute value of x. So here we want to show that it shifts down 6 units. Y equals absolute value of x. If you haven't already caught on, up and down, these numbers are outside of the x, not inside the symbol with it. So down 6 is -6. Again, if you haven't noticed this either, up or down, we don't change the sign here. It's exactly as you would think. So if it says down, it's a -6. And over here, it says 1 unit up. So this is a +1. So that's what's confusing about this. If it's inside with the x, you think about the opposite sign. If it's outside, then it's whatever that sign is, you go with it. So to sum it up over here, if you have x plus k, you move up. And if you have x minus k, you move down. It's exactly what you think it would be. So that's a little summary here. Now let's put them all together. Number 9. F of x equals the square root of x plus 1 minus 3. So first we need to find that vertex or starting point. This one's called a vertex. Here's the h, here's the k. They both have a number. H, remember, it's inside with the x. You change the sign. This is a -1. K we keep. It's -3. So our vertex is -1, -3. So let's plot that. -1, -3. And then I will tell you what to graph from here. I want you to graph -2, 0. And (3, -1). Again, we will focus on those, how to graph them, later on down the road. Right now, it's just the focus is, can you figure out what the transformation is? Mainly from the equation, but see it in the graph too. That's what's really important here. I can definitely explain what I'm doing here right now because I know what this graph is supposed to look like. All right, lastly, we figure out what the transformation is. So let me show the original one more time. The original is a 0, 0. When you're doing these, by the way, before and afters, because you will see problems like this, pick one point to follow, because what we are doing is we are taking this graph and we are moving it every single point on the graph the same way. So if we move this point up 2, we're moving the whole graph up 2. So this goes up 2, this goes up 2, up 2, up 2, all of it goes up 2. So that idea applies. So pick a point to focus on, the most obvious point to you. For me, it's the starting point or the vertex. So it starts at 0, 0, and then we want to do left or right first. So to get it from here to here, it's going to move left 1, and then down 3. To tie it back into the equation, it's what we said here. We change this plus to a minus, so it moves to the left 1 and then down 3. On top of that, it's the vertex, the directions in the vertex. The vertex is -1, -3. So this -1 means left 1, this -3 means down 3, because that's x and y. It's also h and k for these purposes, but on a coordinate plane, this is the x, this is the y. Hopefully you already knew that. All right, 2 more just with the equations. Write the equation of a function with the following transformations from the parent graph, y equals x squared. For number 10, we're going to shift it up 8 and right 12. So this is the format you're going to start with. We have x with the parentheses, whole thing is squared, not just the x, the whole thing. We're making the change directly to the x. And then we're going to have something inside the parentheses and outside the parentheses. Up 8. Be careful because we're going to intentionally switch these up on you to make sure you're paying attention. Up 8, that's a k movement. That's outside. Outside of here is up or down. So since this is up 8, we're going to do plus 8 because outside stays the same. Right 12. This time this is inside the x, left or right is an x movement. So we have the 12. And then remember, when we put it in here, the sign changes. So right 12 is a plus 12, but when we put it in here, it becomes a minus. So that is my equation. So again, this is right 12, and then this is an up 8. Inside changes, outside keep. I actually wrote that up here on the notes. Inside change, outside keep. So if it's inside the symbol with the x, you change the sign. If it's outside of it, you keep it. And remember, this part here is the k. K, keep it the same. Number 11, shifted left 9 and up 5. So again, we're going to start with that same template, if you will. And you can do this every time if you want. Even if one of these are 0, you could put plus 0. There's nothing wrong with that. It's not the most proper way to write it, but it's 100% still correct. Left 9, left or right, that's an x movement. So 9 is going to go here. That's a -9, but remember when we put it inside, we have to change the sign. Up 5, that's a positive movement. Up or down is outside, we keep it the same. So I keep that a plus 5. So inside here, this is read as a -9, and -9 means left 9. Outside, we read it just as it says. So when it says plus 5, that means we are going up 5. All right, that is all for the notes. I hope that you're able to follow this and pick up what is going on. It does take quite a bit of practice to really feel comfortable with it. it's even still something that I have to think about sometimes when I'm staring at an equation. I do really think about this sign changing before I speak, just to make sure that I'm reading it correctly. So if you have to take more time with it, that is perfectly fine. If you have any additional questions over these notes, please come see me in person or reach out to me via email. Otherwise, I hope you have a wonderful day. Bye!